What is involved in solving right angle triangles? It involved the use of sine, cosine, and tangent, what some call SOHCAHTOA. Do you find it easy to solve right angle triangles using the trigonometry, sine, cosine, and tangent? Well, let me know by putting your comment. I'd like to hear your feedback from all the videos you've been watching and my YouTube channel. But now let's get straight to business. Let's talk about the sine, cosine, and tangent of right angle triangles. One area in which we apply the trigonometry is solving questions involving right angle triangles. Of course, you know what a right angle triangle is. A triangle in which one of the angle is a right angle, and by that we mean 90 degree. That means right angle is equivalent or is equal to 90 degree. Now, I have three set of triangles as you can see on your screen. Now, let's look at the first one. Let me call the first one number 1 and call this number 2 and this number 3. What do we notice about these three triangles I have? They're actually three right-angled triangles. Well, for the first one, you notice that the triangle is ABC with one of the angle theta, that is angle C. Now, if I want to define the opposite, adjacent, and hypotenuse of a right angle triangle, what is an easy way to do it? That is what is presented in these three right angle triangles you can see. For the very first one, the side AB is facing the given angle, which is angle C. Now, this is the side AB, and it's facing this angle, angle C, which is theta. Now, this side AB is called the opposite, which means whenever you know a given angle of a right angle triangle, the side that faces the given angle is usually the opposite. And once you can define the opposite, then you can define the adjacent, which is BC. Of course, this side is always the hypotenuse because it is the side facing the right angle. This is a right angle which have a square here, 90 degree. So any side facing the right angle is usually the hypotenuse. So locating the hypotenuse of a right angle triangle is usually very easy. What may be challenging is defining the opposite and the adjacent. So this is an easy way to know it now. Remember, side AB is the side facing the given angle, and that side is the opposite. And then this is the hypotenuse, and this gives you the adjacent, BC. Now let's look at right angle triangle number 2. In the case of this one, you also notice that you have a triangle here, QPR. Now let's identify the given angle. The given angle is angle P, which is theta. Now in this case, look at the side that is facing the angle. So once you can get the angle, just look at the side facing it. That is your opposite. So in this case, QR is the opposite. This is the hypotenuse facing the right angle, and automatically the air becomes the adjacent. So it's important to always locate the opposite. The reason why, because the opposite always changes, but not with the hypotenuse. The hypotenuse seems to be like something we can say it's constant. The side that is always facing the right angle. Now look at right angle triangle number 3. Here you have triangle XYZ. Now what do you notice? The given angle is angle X, which is also theta. Now what is the opposite? How do you locate the opposite side? The side facing the given angle, which is YZ. That's your opposite. And once you can identify your opposites, then this becomes the hypotenuse, the side facing right angle, and automatically here becomes your adjacent. So it is very easy for us to define our opposite, adjacent, and hypotenuse. Now, once you're able to do this, then you are ready to apply what we call SOHCAHTOA. Now, what is the SOHCAHTOA? It's what I have here, the sine, cosine, and tangent of right angle triangle. Right angles, angles in a right angle. The sine, cosine, and tangent of angles in a right angle triangle. That's the SOHCAHTOA. So sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. Now, this is an acronym to help you remember what they stand for. SOHCAHTOA. The S is for sine of the given angle, sine theta. The O is opposite. The H is hypotenuse. So once you're given the opposite and the hypotenuse, it tells you that to solve that right angle triangle, you use the sine. But if you're given the adjacent and the hypotenuse, you're using the cos. And that's the CAH, CAH, where C is the cos of the given angle, A is the adjacent, and H is the hypotenuse. But if you're given the opposite and the adjacent, it means you're going to use the tan to solve, and that's the TOA. So the T stands for tan of the angle, in this case tan theta. The O is the opposite, and the A is the adjacent. Now, having understood what SOHCAHTOA is, let's now apply them to solve right angle triangles. Now let's look at some questions where we apply the SOHCAHTOA. We are asked to find the length of the marked sides. Now, in number one question, we're given a right angle triangle where you have the given angle as 42 degrees and one of the side is 7 centimeter, which is known. But the marked side here, it's what we are looking for, which is x. Now, what will be the first thing I'll do? Because that will determine either I'm going to use sine, cos, or tangent to solve the question. So the first thing I will do here is to identify the opposite. Now remember, once you know the given angle, the side facing the given angle is the opposite. So this is my opposite. Define that first. Then this marked side x is facing the right angle. That's my hypotenuse. So this tells me I am going to use the sine to solve this particular question. So it's going to be sine of the given angle. In this case, sine 42, it's equal to opposite, which is 7, divide the hypotenuse, which is x. That's the solve. The sine of the given angle is equals to opposite all over hypotenuse. Now, when you have a question like this, what do? You cross multiply. The x will take the sine 42 position. So it becomes x equal to 7 divide sine 42. So sine 42 takes the position of x and x takes the position of sine 42. This way, we can get a value of x. So what you do is you're going to use your scientific calculator. Check out the value of sine 42. Then 7 divide that value gives you your answer. So in this case, it's going to be 7 divide sine 42. And that will give you your value. So let's find out what is sine 42. Now use your scientific calculator and tell me the value of sine 42. So the value of sine 42 is 0.6691. We're writing it to 4 decimal places. And if you divide 7 divide 0.6691, you're going to have 10.46 centimeter. Okay, so let's move to number 2. Number 2 question, I'm giving the angle 51 degree. I'm giving the hypotenuse as 12 centimeter. Now the side facing the given angle is the opposite, so there's nothing there. Where we are looking for is the adjacent. This is the hypotenuse. So it tells me I'm using cos. So it's going to be cos 51. That gives you the adjacent y, divide the hypotenuse 12. You cross multiply, so it's going to be 12 multiply cos 51 equal to y. So what is cos 51? Cos 51 is 0.6293. So if you multiply 12 times 0.6293, it gives you the value for y, which is 7.55 centimeter. Number 3, we're given the angle 12 degree. So the side facing the given angle, it's your opposite. Very easy to identify. This is your hypotenuse, the side facing the right angle. So this gives you your adjacent. So here we are given the opposite and we're looking for the adjacent. So it means I'm using tan. Tan 12 will give me opposite over adjacent, which is 7.5 divide A, and that's my adjacent. If you cross multiply, this will be A equal to 7.5 divide tan 12. What is tan 12? The value of tan 12 is 0.2126 to 4 decimal places. If you divide 7.5 divide 0.2126, it will give you 35.28 centimeter. That is the value of A. Now, number 4 question is very interesting because here we are looking for theta. We're given 2 sides, but we don't know the angle. Again, the first thing we'll do is to identify which is the opposite. So this is the opposite, the side facing the given angle. This is always your hypotenuse, the side facing right angle. And so this is your adjacent. So we're given the adjacent and we're given the hypotenuse. So this tells us that we are using cos. Theta equals to adjacent 5 divide the hypotenuse 13. Cos theta will be 5 divided 13. If you use your calculator, you're going to have 0.3846. But we're looking for theta. So how do we get theta? Now this is what we'll do. This is equal to, we'll take the cos inverse. This is how you write it. Of this value, 0.3846. If you take the cos inverse, to do this, you go to your calculator. You have where you call the second function, or like most calculators will have the shift. Just touch that and touch the cos. You will have this symbol comes out, the cos inverse, as if cos raised to power minus 1, and then impute this value, 0.3846. And then equal to is going to give you this value, 67.38 degree. So this is the answer to the question. Please feel free to tell me how you see the whole lesson. If there are any challenges from what I have solved, you can let me know by putting it in the comment section. If there's a particular question you want me to solve, please put it there. Remember to always subscribe, like my video, share. Thank you so much.